All right, so when I say in the last lesson, I meant last lesson, like not that word, but this. We learned that arithmetic sequence behaves like what function? Linear function. And geometric sequence acts like a exponential function. So this chart here is a lot. I agree, a lot, but it kind of makes sense, okay? All right, so I just put it side by side. Arithmetic sequence, a sub n is equal to a sub 0 plus dn. You are more familiar with this. A sub 1 plus dn minus 1. The top one just comes from the fact that when I just took 0 and then plug into the k here, and it becomes this. So you can memorize it. You don't necessarily need to know that to come up with the equation, but to memorize, you don't have to memorize it. You just have to memorize this, right? That solves all our problems. Okay, where n is the nth term and a sub n is the output. Linear function, f of x is equal to b plus mx. Mrs. Major, we thought it was mx plus b. It's the same thing, folks. The reason why I put mx in the second is because over here, remember that common difference comes the second term. I just want to match that. That's why you write it like that. You can find mx plus b. That's fine as well. And we also learned the point slope form of the bell work, why that is that it is. So that you use this if you have a slope and you have a xi comma yi, a point. Then you can just plug it in. Okay? All right. Geometric sequence is when things are being multiplied, the common ratio r. So g sub n is equal to g sub k times rn minus k power, but we learn it more as g sub n is equal to g sub 1 times r to the n minus first power. Just know that that's a variation of this. I just put that 1 instead of k. If you put 0 instead of a k, you get the following over here on the top. Exponential function, y is equal to a times b to the x power, or y is equal to a times r to the x power. Depends on what variable you use. Some people use b as a base. Some people use r like so that you can match as a ratio. Either way, I don't care what you use. Okay, so very similar. All right. So, how are they similar? How are they different? Linear and exponential function. Linear looks like same slope, right? So between the y value, you're adding the same amount. What we call it? Common difference. Right? So over equal length input value interval, the output value changes at constant rate. Constant rate. And what is that rate? The slope, the common difference, all the same thing. And it changes in the addition. So it goes like 5, 8, 11, 14, 17. You're adding 3. Or 10, 8, 6, 4, 2. You're subtracting 2. Minus 2 is your addition. That's a linear function. What about exponential function? It looks something like this, right? Over equal length input value interval, the output changes proportionally. So it's not the same amount, but like proportionally, like 92% of each one or half of each one, right? So this one looks actually more like a half. Change of y is based on the multiplication. I know that's a little confusing because you're like, why? Well, multiply by the ratio. So on that bell work we did over here, you're multiplying by 0.972. That's your common ratio. Decrease 2.8% is having 97.2%, which is the same as that. Okay? So don't get confused. Linear function, arithmetic sequence, you add the same amount. Exponential function, geometric sequence, you're multiplying the same amount. Okay? And the nice thing about it is that both of them, if you have 2 points, you can find out what the equation is. So let's do that then. Selected values are several function tables below. Each of them determine if it's a linear, exponential, or neither. Give a reason. Okay. All right, first thing first, make sure your x is increasing the same amount. Ooh, 0, 3, 6, 9, 7, 12. That's good. What about the y? What do you notice? It's decreasing by 2 throughout the whole thing. Okay, so over equal length of interval value, your y changes at the constant rate. Y is changing the same amount, so this is a linear. Reasoning, remember, is very, very, very important. So let's write it down. Over equal length input value, meaning x is increasing the same amount, the output value change at a constant rate. That's like a formal definition of it, or you can just say the output is decreasing at the same amount, or all of that are same, or common difference of -2. Those are all the same explanation, but this is like the textbook way. Okay, what about next? X is increasing the same amount, so that's good. Look at the y value. +1, +3, +5, +7. So are they the same amount? No, so it's not a linear. Now, do you feel like you can multiply the common ratio from one to the next to come up with it? No, I can't. 1 times 4 is 4, but 4 times 4 is 16, so that doesn't work. It's not the same common ratio. So this one is neither. Why not? Over equal length input value interval, the output does not change at a constant rate or proportionally. It's neither. Okay? But this, x is increasing the same amount, y is, let's see, 1 to 2, +1, +2, +4, not linear, times 2, times 2, times 2, times 2. So it's a proportionally increasing, right? The common ratio of 2. So it's an exponential because over equal length input value, the output value change proportionally. I can't spell proportionally. Bad handwriting, but you got the point, right? Okay, what about this? X is increasing the same amount. That's good. Y? -40, -20, not right linear. Half, 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 half. Ooh, you multiply by half. And remember, you're finding what number you're multiplying. Mrs. Major, what if it's a dividing? Well, you multiply by reciprocal, right? So this is exponential function because over equal length input value, the output value changes proportionally. Please memorize that say. Okay? All right, next problem. This is going to be like similar to your last few problems on your IP, so pay attention. And this is the hard part. Well, kind of. While rumor spreading, okay. Honestly, I kind of skipped the first part because I don't really need to know that. I'm just going to focus on the part I need. Okay, we are using geometric sequence. Good to know. Where 43 people had a rumor on day 3 and 40 people on day 6. Do you see how I'm underlining things? Very important you do that on your AP exam. Skip the part that you don't need. Circle, box, underline information that you need so you can translate that into the math equation right away. Okay? According to this model, how many people nears the whole number? So we got to round it up. Day 10. All right, so here's what I will do, and I'm acting like I'm taking AP exam. Geometric sequence, okay. So G sub n is equal to G sub 1 times R n minus 1. I write that down. First, on day 3, 43 people. On day 3, 43 people. On day 6, 140 people. Right, so I just translated those sentences into mathematical equation. Do you remember at the back of the last lesson, we says, if you have 2 points, you can write it. You can write the function. Okay, all right, got it. So I got 2 points. Let's plug it in. G sub 3, I take that 3, plug it into n, equal to G sub 1, I don't know what that is, R, I don't know what that is, 3 minus 1. G sub 3 is 43. I got that. All right, what about G sub 6? G sub 6 is equal to G sub 1 times R, 6 minus 1. 140 is equal to G sub 1 times R to the 5th power. All right, let's write that down together, side by side. So I got the 2 equations over here with a 2 variable. Remember, with the geometric sequence, what do? You divide top by bottom. Okay? All right, then on the right side, it cancels out. I'm left with 1 over R to the 3rd power. equal to, what is 43 divided by 140? Please be a pretty number. It is not a pretty number, so I'm just going to leave it as 43 by 140. Okay? All right. This is a little tricky, so bear with me. I'm looking for r cubed, so, and it's in the denominator. So are you guys good with it if I write it like this? R cubed is equal to your reciprocal, 140 over 43. What do you think? Is that okay? Yeah, right? How do you find r? You cube root both sides. So cube root of 140 over 43. I don't know what that is. I'm just going to leave it like that. Okay? All right. In fact, let me show you a cool tricks on your calculator. Well, how do you do a cube root? There are many ways you can do it. You can go to math. Go to number 4. There's cube root. 140 divided by 43. Or if you don't like that, do you know that cube root is same as 1/3 exponent? Do you know that from algebra 2? Say yes. All right. Well, then I can just do 140 divided by 43 caret 1/3. I still get the same answer, so it doesn't really matter which way you plug it in your calculator. Now, I'm going to teach you how to store it. Okay? Store. What do I mean by store? Like literally store it, so that you don't have to type all of this. You never want to round up your math answer in the middle of it, then you get the wrong answer. So you have to save that in your calculator. Do you see the STO button? Okay? Push that. That means you're going to store that answer as a something. You have to pick a variable. I personally like to just use those green ones. So green one, alpha A, and hit enter. Alright, and the magic happens. Now when I do alpha A, that's how I stored my answer. Isn't it cool? Yeah, you can store as a B, C, doesn't matter. Alright, now, I'm not done here, because, what am I finding? Day 10, day 10. So we're looking for G sub 10. So G sub, oh, we're far away. Okay, so go back over here. I need to find the G sub 1 as well. So 43 is equal to G sub 1 times R, this whole thing, square. Right? So G sub 1 is 43 divided by this whole thing. Woo! Let's plug it in. 43 divided by, that was an A, right? So A square. 19.5 something. That is your G sub 1. So the whole equation is going to be G sub n is equal to this whole thing, 19.57. I'm not going to round it up. I'm just going to write it down here, but I'm going to save it as a B actually. Store as a B. So that times the R cube root of 140 over 43 raised to the, what are we looking for? 10th day. So 10 minus 1. 9. So bear with me. That is B. So B times, that is A raised to the, what power? 9th power. Then we got G sub 10 equal to 675.576. There you go. See, I rounded up to the thousands. I did not round up any of my answer in the middle of it. In fact, no, you cannot do that. You get the wrong answer. You can only round up your final answer. There you go. All right, this video is getting long. I'm going to start the next one to finish up.